Hi, welcome to the Data Tech. Yeah, that's me. I'm seriously working on something. Yeah, this is Google Cloud BigQuery. I try to learn so many stuff in BigQuery and then I try to identify solution for my problem. And so we're gonna discuss about clustering.
So now I'll just show you the DDL of the clustering table. So I just created a table here. Test data is my dataset name. That is something like the database name in RDBMS. In BigQuery, we call it as dataset. So test underscore data dot cluster table. So now I'm going to create two tables. One is with clustering and one is without cluster. And then I'll be loading some records into it. And then I'll perform a filter condition. And then let's see the performance between these two tables. Now, I have five columns here and then cluster by. This is a keyword that you have to use to create a cluster table. So the last underscore name is the column which I'm assigning for the cluster by. Okay, what a clustering will do. The column what you assign for cluster, right? So it will perform a sorting of your entire records in that particular table based on the column that you have given for the cluster by. Now, whatever the rows we insert, so based on this column name, the last name, the values will be get sorted. And so whenever you do some filter condition, so your query performance will be good. Now the question is based on what you decided last underscore name should be assigned for cluster by. So we have first name, age, city, why, last underscore name. You can even have more than one columns as part of the cluster by, that is possible. But here even though it is more than one column, that how you are deciding the columns. So now imagine that you have the downstream and the downstream is going to use this table and they have always performing the filter condition based on last name only. In that case, that is going to be the filter condition. The entire performance is based on how the query is filtering the last name. So in that case, I'll be using last name as part of my cluster by. If it is something like account ID or like some of the primary key field, then you can give that as part of the clustering. So clustering, what actually it is doing is it is sorting the rows based on what column you assigned for cluster by. So you can use partition and cluster in the same table also. The performance will be really good. Okay, now you may get a question. So here you said cluster means it will sort the data. So instead of using cluster, during the select query itself, I can use this order by, right? So order by last underscore name and then I can give ascending order. So this is also going to sort the data, right? Yes. The difference is order by you will be using in the select query. And this is the data which you are stored in the hard disk will not be get changed, right? So when you do a select query, only during the time of select, it will read and then it will sort and then it will apply your filter condition. But when you use this cluster by, right, you are creating the table as cluster by and then you are loading the data. So here your data will be physically sorted and stored in multiple files. For example, two people have the same last name means then these two people record will belongs to one single file so that it won't be in a different file. Okay, so that means cluster by is physical, your data will be physically sorted and get stored, whereas order by is logical, only during the select it read and then sort and then apply the filter condition, so that you can see the difference between. So cluster by and order by is not same, okay, with respect to performance. That is something you should know for sure. So let me get into the practical. So this is my BigQuery UI, and this test data is a data set that I have already created. Now let me create a table. So just click this, you see the option create table. And here I'm going to give a name for my table. So let me give it as cluster table. And then I'm going to create the schema. Okay, so I have ID and then first underscore name, last underscore name, age, and then city. Okay, so I'm just creating five columns. Now I need a data set, right? So I'm not going to insert it manually because just to see the performance between two tables like cluster and non-cluster, we need at least 10,000 rows so that we can able to see the time difference. Just 5 rows or 10 rows will not give you the performance difference. What I'm going to do is I'm going to generate a data set and then I'll be loading it here. So you have something called upload. So you can upload it from the various sources We can even upload it from the local system. So how about data? How we are going to generate data? So let's use ChatGPT for that. So I already have the prompt here. So create a CSV file with 5 columns: ID, first name, last name, age, and city with 10,000 rows. Enter. So this will create a CSV file for you, and we can load the CSV file into our BigQuery table that we are creating. Okay. So now you can see the CSV file is ready. Just click it, and I'm just downloading it in my pictures folder. Okay. The file is ready. Let me open it. So you can see like it just created some 10,000 records. Now I have to load it into my BQ. Okay. Back here, I'll say upload and then browse pictures, random underscore data. Fine. So now create the table. So now I'm going to create another table, create table. So it's again going to be upload same file. I'm going to upload the same file. Okay. Now the table name is no underscore cluster table. So I'm not going to create any cluster here. So now the same schema, ID, first underscore name, last underscore name, age, and then city. So no partition, no cluster. Just to create the table. Okay, table got created. So we created both the tables now. Now let's see the query performance difference between these two. So now, like I have the table, clustered table with the condition as last name as John's. Let me run this first. And you can see the result and just go to execution details where I can see 219 milliseconds. Now let's go to no cluster table, same condition. Let me run this. Okay, so we are getting the same result execution. So it is 239 milliseconds. Whereas if you take clustered table, it is 219. But then if you take the non-clustered table, it took 239 milliseconds. So elapsed time means it's overall time, including read time, computation time, and everything. And even you can see the slot time. The slots is like virtual CPUs, which BigQuery used to compute the job. For no cluster, it is 41 millisecond, and for clustered table it is 34 millisecond. So even if you couldn't see this difference in your machine, right, sometimes people will say non-cluster table is taking faster time, but the cluster table is slow because the data set what you are giving is very small. Clustering, the actual advantage only comes into picture when you go for bigger data set. So we have seen the difference between. And thanks for watching. If you really like this video, please do subscribe my channel and forward this to your friends and colleagues. And please do share this in your LinkedIn. And we do have a lot of other videos in cloud, big data, programming language, and APIs. Just have a look. Thanks for watching.